All right, let's do an example with this stuff. So we have the Arth order statistic, which if you'll recall, comes from taking some number in of independent identically distributed, IID is the acronym for that, random variables. F, capital F was the CDF for those random variables, and little f was the CDF, or was the density or the PDF for each one of those individual random variables. And what we discovered is if you take the Arth order statistic, which remember that was called Y sub R is just the Arth one of those x's if I were to put them in increasing order. And the fact that I can put them in increasing order was simplified by the fact that all of the x's came from a continuous distribution, so there was no danger of equality. Now again, you could do all of this analysis for discrete situations as well, but you would have to contend with the fact that equality is a possibility. So that was that's a little bit annoying. All right, so here's the example that I wanted to do. So suppose, okay, so here's an example. So suppose that I have 5 random variables, x1 through x5, each are IID, okay, independent identically distributed, with common density f of x equal to 2x, and that's for x between 0 and 1. Okay. Then of course, what would the CDF be? Okay, so the CDF for the x's is capital F of x, and if you want, you can say that this thing is, you could just integrate the density, so this would be x squared plus c, and then we could ask the question, what in the world is c for this thing? Okay, so what is the constant of integration here? Well, you can use facts that you know about this. So first of all, if I were to integrate this density from 0 to 1, okay, it needs to be 0 elsewhere, right? It will be 0 elsewhere. And in particular, it will be 0 at 0, right? This thing matches up at 0. And so capital F of 0 is 0. Okay? So capital F of 0 on the one hand is 0. And on the other hand, this is going to be 0 squared plus c. So what does that tell us about c? C is equal to 0. Okay? So that tells us that the PDF for this thing, okay, so the PDF for, or actually the CDF, sorry, the CDF, cumulative distribution function for x1 through x5 is capital F of x equal to x squared for 0 less than x less than 1. Okay, and it's equal to 0. So let me just kind of write it this way. It's 0 for x equal to or less than 0, and of course, it's 1 for x equal to or greater than 1. Okay, so it has the typical shape of a CDF. Now let's see, so what does this thing look like? Let me kind of graph it. Maybe I'll use red for the graph of this thing. It's equal to 0 everywhere before 0, and then the minute I get to 0, okay, here's 1 and here's 1 right here. The minute I get to 0, it starts going up on this line, or actually, hang on a second, that is not how this thing looks. It's a parabola, right? So it's the parabola like this, okay, and then it's equal to 1 after this. There we go. All right, so so we have that. Okay, and now remember, okay, and it goes backwards like that. Remember, we have our our formula for the densities, yes? So what are our densities are right there, okay? So n factorial over r minus 1 factorial, n minus r factorial, okay? Let's just kind of write down all the densities, okay? So see, what are the densities, okay? Just say the densities for, okay, so let's see here, y1, well, it's going to be g1 of little y equal to, well, remember, so let me just kind of up here at the top write down the formula so that we don't have to keep remembering it. So gr of y is equal to, so it's n factorial over r minus 1 factorial, n minus r factorial, okay, times what? F of y to the r minus 1 times 1 minus f of y to the n minus r times little f of y. Okay, so where big F and little f come from the common distribution that we started with for the x's. Okay, so what is g1 of y? Well, so g1 of y, again, what's our n equal to in this particular case? Well, n is 5. Okay, so g1 of y is equal to 5 factorial over, okay, r minus 1 factorial is just 0 factorial, and then n minus 1 factorial is 4 factorial, okay? And then it's f of y to the r minus 1, f of y to the r minus 1. So what's f of y? Well, okay, so f of y to the r minus 1, capital F of y is just x squared, right? So that's going to be y squared to the r minus 1, which is 1 minus 1 in this particular case. And then it's going to be 1 minus f of y, which is y squared, to the, right, n is 5, so 5 minus 1. And what was little f of y? Well, if you'll recall, if I go back to this previous slide right here, f of x was equal to 2x, right? So f of y is equal to 2y. Okay, so then this is just multiplied by 2y. Okay, so what does this end up being? g1 of y is just 5. It's 5 factorial over 4 factorial is 5 times 2 is 10. The y squareds just go away completely here, and I have just a y, and then I have a 1 minus y squared to the power 4. Okay. What about for y2? Well, I get g2 of y. Okay, it's going to be 5 factorial over, okay, so 5 factorial over what? Over 2 minus 1, which is 1 factorial. And it's going to be 5 minus 1, or 5 minus 2, which is 3 factorial. Okay, and then what's it going to be? It's going to be y squared to the 2 minus 1. So it's going to be y squared to the first power this time. And then it's going to be 1 minus y squared to the 5 minus 2, which is 3. And this is going to be multiplied by 2y again. Okay, so what is this going to be equal to? Well, 5 times 4 is, right, because the 3 factorial cancels everything on down. 5 times 4 is 20, times 2 is 40. 40y squared, actually it's going to be y cubed because of the extra y at the end there. So it's y cubed times 1 minus y squared cubed. Okay. And then, let's see, I'm going to erase this over here, and we're going to write some stuff over here. What about for y3? Well, it's g3 of y. Okay, that's going to be 5 factorial over, let's see, it's going to be 2 factorial. So n minus r, so there's another 2 factorial. And it's going to be y squared raised to the power 2. And 1 minus y squared. 1 minus y squared to the 4th times 2y. Okay, which is what? So we get a 2 that cancels, and 5 times 4, right? So we get a 2 that cancels here, and then another 2 cancels that, so it's going to be 5 times 4 times 3, which is 60 y to the 4th power, and then it's 1 minus, or actually it's going to be y to the 5th power because of the y at the end right there as well. So it's y to the 5th, 1 minus y squared to the 4th. Or hang on a second, that was a slight mistake. Sorry about that. This should be, the power should be decreasing. It was 4, then it was 3, now it's 2. Sorry. So this is 2, and then this guy right here is 2 also. Okay, so we have 60y to the 5th times 1 minus y squared squared. And incidentally, all of these are defined for 0 less than y less than 1. These are the densities for 0 less than y less than 1, and they're equal to 0 outside of this range. Okay, so almost done here. Hang on a sec, we'll go to the next page and finish this off. All right, copy this down on the next one here. So we have g4 of y equals, okay, what's going on here? It's going to be 5 factorial over r minus 1 factorial, which is 3 factorial, n minus r factorial, which is 1 factorial, okay? And it's going to be y squared, right, which is the CDF, y squared raised to the r minus 1, okay? And r is 4. Here's just the 4th order statistic. 4 minus 1 is 3. And it's going to be 1 minus y squared to the n minus r, which is 1. Okay. And then we have this multiplied by the density, which is 2y. Okay, so what is this? Well, let's see here. We're going to have 5 times 4 divided by 3 factorial, which is 20, times 2, which is 40. Okay, y to the 7th times 1 minus y squared. Okay, and then the 5th order statistic is going to be g5 of y is equal to 5 factorial over what? Over 4 factorial times 0 factorial times y squared to the r minus 1, which is 4, times 1 minus y squared to the n minus r, which is 0, times the density. So what do we get here? This is going to be 10 times y to the 9th. Okay, and there are all 5 of our densities corresponding to the order statistics. We'll look at a graph of these next, and we'll consider that to be a day. All right, here are the densities. I've kind of put each one of them in here just so you can see them on full display here. So as you can see, what I did here was I just straight put in each one of those. Here's G1, 2, 3, 4, and 5. So the red curve is the first order, second order, third order, fourth order, and this should be G sub 5, just so you know. 5th order statistic here. Okay, and what's amazing is you could kind of tell which one is which. After all, the first order statistic should, on average, be smaller than the other ones. And the second order statistic should live between the first and the second. So you can kind of see that that red curve corresponds to the first order statistic. So it's not surprising to see that most of its probability is humped up near the tail end. And the second order statistic, which corresponds to the blue curve, is the next one. And then the green, and then the purple, and then the black is the fifth order statistic, the largest of all of them. It's the biggest one of all, right? So I could zoom out a little bit so that you can kind of see this thing actually stops right here. And all of these densities are, of course, zero outside of the interval from 0 to 1. And of course, you could actually take these densities and easily compute the means. Now that we have these densities in hand, we can easily compute the means of each one of these simply by integrating y times each one of them. And you wouldn't be surprised at this point to discover that the mean of the first order statistic will be smaller than the mean of the second, which will be smaller than the mean of the third, which will be smaller than the mean of the fourth, which of course will be smaller than the mean of the fifth. Okay. So that's just a nice little application of that general formula that we came up with. That's all for now. See you soon.